All right, I'm claiming that we are seeing leptons, and these are the only particles that exist on their own. This is the Large Hadron Collider. They force nucleuses together, explode tons of particles. We're using tiny particles. We're using electrons. They're using things like this, smashing them together and seeing what comes out. We're using things like this, and then seeing what that decays to. That's the difference. Now, and they go down through all the different particles that exist, and then it says leptons are the elementary particles that exist on their own. The other ones are quarks, antiquarks, hadrons. They're all elementary particles, but the leptons, and here's where the universality goes awry, they say. Now, I showed you what I consider to be the leptons, the black ones and the white ones. They're both leptons. One is the weak force and one is the strong force. All right, don't forget, we started with electrons, which is light. Light is the smallest particle there is. And then we put it through the Venturi. We ended up coming out with muon neutrinos, electron neutrino showers. Now, tau neutrinos, I'm not sure about that, to be perfectly honest with you. But these I know we see, which that's what we're seeing. And an electron is a little different. Well, these are the leptons. And we're looking at the electron neutrinos because they're quite visible. All right, this is a little tricky, but it's not really hard. Electrically neutral means you have an equal number of both things. Now, think about the electrically neutral leptons, which I'll show you in a second, which are neutrinos. Nature also treats all of them equally, and they should all likely to decay into neutron antineutrino pair of electron muons. They don't. There's a problem. That's called universality problem. And they admit there's no way they can cover for it because they don't understand electron flood theory. I can show these particles decaying. Now, whether they can see them better in the way I do it, they might be able to. Neutrino is the black ball, electron neutrino is the white ball, and they're glued back to back. It's a photon. All right, that's what they look like back to back. They're photons. There's a strong force and a weak force. The weak force is the black, the strong force is the white. And that's all that makes up matter is these electrons. And when they concuss, the white one explodes, the black one just rolls away. All right, here's your leptons and quarks. What it breaks down to is if you have a strong enough pulse, you can break these things up as I'm showing you, which is the tau. I believe that's really the photon. And then you get the muon and the electron. And then as they start to concuss and congeal, they turn into this tau neutrino, which I don't think exists. But I do know the muon and the electron neutrinos do. And I can show you the muon and the electron neutrino. Those are the smallest particles that exist. Okay, I must apologize. I've been doing 6 things at the same time. I'm sure I showed this before. I'm going to show it again. That's the black ball, and it does not change when it concusses. This is the white ball. It explodes when it concusses. That's what they call, I believe, the electron shower, electron neutrino, electron shower neutrino. And we see it do that. And the muon neutrino, which is attached to it, doesn't do anything. It rolls off as the black ball. I'm sure, like I say, I got lost in this several times, so I'm sure it's a mess. I hope you can make something out of it. Now don't forget, we're talking about subatomic particles, and you can see these with a cell phone, and I could show you, you can see them in your own house with your own cell phone, see subatomic particles. Now what are we looking at here? Pulse red laser. It's not a wave, it is a ball. A magnetic region and a tiny dot in the center owns it. And as it pushes all the particles that are in front of it, they start to glow according to the frequency of the light that's passing through it. If it's completely white, it'll be white. Now, what happens is it approaches a Venturi. That's a Venturi restriction, like 2 airplane wings, forcing everything, which is these balls. Okay, they're not just a tiny, they're these balls. there's this much of an influence. They have to squeak through this. The dark spots leave and the white spots explode. And here's what these particles are. They are pulled out of that wave, as you can easily see. Before, it was just this. And it would never do anything other than that unless we approached this Venturi and had to accelerate. So now we have a particle, and here's the particles. Here's what the particles are. The black and the white and the black and the white. Remember I talked about the equal neutral particles? You got everything's the same. There's two of these and two of those. So that's neutral. Now, eventually we can break the black from the white, because as we hit the Venturi, they just go into chaos, and we're going to see that right now. All right, here they were a second ago, and now they can't get through here because the whole thing is in chaos. Total whiteness, the little black balls are all over and rolling around here. Now, again, I think I stated this before, or I will later. Are those the same black balls that will attach to the same white balls, or will they find something equal? Is there an equal number? And they say no, there's 80% of one of them or the other. So they're missing 20% of something. Now, is this dark matter? I don't know. Why does some of it convert during the process of these interactions? And that may be possible because I can show you a conversion. All right, now it's coming through the Venturi at us. All of these were red light. You see that? That came through backwards, and I'm going to show you what happened to it. In addition to that, you see that one is turned purple? This has re-accelerated itself because it's being crushed on both sides. I'll show you that. So there are some things that do happen after they assume this. These are the electron showers, so that's the white portion. Then we have the black balls. I don't know what they do, because they just roll around. They can lay on top of each other and do whatever they want. I think one of these finally grabs one of them, or one of them grabs one of these. I don't know, but eventually I'm absolutely sure they come back together. Pretty sure. Okay, that's the little white particle coming through. It concusses with a normal particle, and it does this. Now that's I don't know what it is. It is what it is. But the point being is maybe there is some interaction here, something changes. I'm seeing something change. I don't know how it affects their calculation. Now that other one, that reverse little trumpet looking thing, that's extremely rare. That's the only time I've ever seen it. Now here comes a whole shower of the electrons, just electron showers, and then the pinches, see, pinch, 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 and that one there, which was red a second ago, turns blue, and then it fades back to red again. So you can, I don't know what that means, but anytime you see blue, that is much more energetic than red, and you can see it's like less spread out. It's more concussed. So and that's after the Venturi. And this is in its fermion phase, which means there's no black ball attached to it here. It's very interesting stuff. You see, this is where they all come back together and they start grabbing a hold of the black balls and they start turning into normal looking, it's still highly energetic, but it's getting back to normal. Now, did we lose some of the black ones? Did we lose some of the white ones? Did we gain something? Did something convert? All that's up in the air right now, because this is electron flood theory. I'm sure I showed this, but can never show it enough. All of the cores of atoms are made of resonance stable frequencies of dipole electrons. So helium has 7,350 electrons in the core. That's 2 protons of 1,837 apiece and 2 neutrons of 1,838 apiece. And then you have, it influences a very limited amount around itself. Right? Same thing with hydrogen, but it's whatever is close to it. It's highly energetic, but it's, helium is very stable. Let's not bother getting into all that. But what it boils down to is the core is not made of a couple of protons and a couple of neutrons. Absolutely not. thousands and thousands of particles are in every single atom, in the tiniest little atom, and all of the little tiny ones, thousands. So now we can really do some chemistry. Before, there was no way to account for all the isotopes and all the different elegance of chemistry. No way in the world could they account for it. With electron flood theory, it's very simple. I can literally now, I can't find anything that I cannot show it works with electron flood theory. There's nothing. Absolutely, Schumann resonance absolutely works flawlessly. Everything, all of the mysteries of science work exactly perfectly. And in addition to that, all of the Mudfossil stuff shows that that's all really a big problem, the geology. And it's in space too. And it relates to the asteroid belt. I'm going to get into that because that was a planet at one time, I believe, just like the Earth is right now. And it exploded or something happened to it. Now, Velikovsky was talking about all this and the cosmos in chaos. And I'm telling you right now, the things that are floating around out in space are biology. Absolutely, I have the evidence to show that as well. And they have it at NASA too, or European Space Agency, where they landed on the Rosetta mission, Philae lander, landed on Comet 67P. And I followed that from day one. I have videos go back 5 years. They found everything on it was organic, and I saw everything on it anatomically is exactly what I portray it as, and I have the videos to show it. Anatomically, chemically, everything, biologically, it is what it is. So it's time that everything is looked at totally new. And electron flood theory puts everything in a new realm as far as chemistry goes. And again, geology, you just got to start over with that one. And Tyson is the guy that is holding all the cards here. Tyson's Mudfossil Adventures. Go there and look at the stuff he's presenting. Now, and he does pretty good research. You listen to what he has to say. He's very knowledgeable on this stuff. We work together daily. And he knows what he's doing, and he's got a spot that is just unmatched. You know, for easy, well, it's not easy access. He's doing a lot of work doing this, and it scares me. I got to tell you the truth. Some of that stuff very slippery. You get clays and things like that. They are just as slimy and slick as you can get. And he's on the ocean, and he's way, way up in the air. Because these things were absolutely enormous. Let's just look at a membrane. Alright, remember I showed you the black balls and the white balls? This is what they're talking about, and they're saying one comes back 25% less often than the other. They expect them to both come back the same. And I would too. If they went in like this, you'd expect them to come back for the same number of particles once they came back. Now, maybe, I don't know what happened to the other 25%, but listen to what she has to say.
And it definitely wasn't significant enough to get really excited about. Since that time, we've been analysing all of our data, and what we've measured now with higher precision is that muons seem to be produced in B-meson decays 15% less often than electrons are produced.
All right, so what she's saying is the black stuff is coming 15% less than the white stuff. So the black balls and the white balls don't equal out again. How did that happen? I don't know.
This is a tantalizing result because it's not yet definitive. There's still a chance, a small probability of 1 in 100, that what we're seeing could just be a fluctuation from B-mesons decaying to electrons and muons at the same rate. So in order to be absolutely sure, we're going to have to analyse more data to get that final significance. But the reason why this is so interesting and thrilling is that, besides being unexpected, this could genuinely be the first sight of something new. Because if, when we've analysed more data, this difference between muons and electrons stays, and lepton universality seems to be violated, well, what that means is that there's something wrong with the standard model. We found the crack, finally, in our understanding of particle physics.
Well, yes, I agree with that. But I also want to say that the electron flood theory, which replaces the core with particles of electrons, which are the ones I showed, the positive and negative together, and only the negatives explode. The positives are the carrier, they're the weak force. You have weak and strong. They've always said this. I'm saying exactly what they say and what they were looking for, and I'm showing it now. Does that mean, as I say, that the nucleus is made of those electrons? I say it does, because this accounts for every isotope, which means isotopes are what happens in between these particles. You think it just goes from, magnesium to iron, boom, bang, done, case closed? No. In between is all kinds of different numbers of electrons that can still make semi-stable and stable configurations of magnesium. And the same thing with iron. And the same thing with all of them. They all have a ton of different isotopes, which means they have a ton of extra or not enough of electrons that would normally be to configure it. That's what an isotope is called. And you can't do them with what they say is just protons and neutrons. You cannot make that elegance. And you can't, no way you can make the chemistry that you can make when you start to break them into every proton is actually 1837 electrons. It makes a lot of difference what you can do with 1837 electrons versus one proton. And that's why chemistry is so elegant. And it all relates to heat and temperature, and all it is driving off an electron here, driving off an electron there, because that's all temperature is extra electrons. You force electrons into something, you're heating it up. You suck them out of there, you're cooling it down. Simple as that. And they are only electrons. You end up with the same base material, but it's just hotter or colder. All right, at some point, it will evaporate or it will explode or whatever. It depends on how many you suck out or how many you push in. And that's why you get molecular changes when you start to reach certain temperatures. This changes to this, then it changes to that, then it changes to this. These different molecules their electrons will be so shaky that they'll mix and then all of a sudden end up with something like that, which is a different molecule than you started with. And that's what alchemy is. And what alchemy is really cool with alchemy is using biological things to do the breaking. Because the biology does it better than, well, it does as good as heat anyway. Because what happens is you take yeast and bacteria and all that, they squirt out enzymes which are so elegant. And that's why you see all these bubbling coming up. That's nothing more than boiling. It's identical to what boiling is. Identical. It's pushing electrons out. Sometimes they come out of different gases and carbon dioxide and so forth. Obviously, they're coming, but they bubble right out of there, and that means you're pushing electrons out, and that means you're breaking molecules up, and that's what fermentation is, and that's what alchemy is, and that's what we need to do inside of our guts, is have the correct bacteria to break up the molecules to give you the healthy foods. If you could do the alchemy and have the actual bacteria create the products, because that's what they do, they get rid of all the other stuff we don't need to get out of here and give us the metals, the minerals, the this, the that. Although you do need a lot of bulk. Bulk is very, very, very important. They're finding out it's extremely important. I've always been taking Metamucil, so I really didn't think that much about it. But some people don't. You need fiber. You need fiber. All right. Anyway, because it slows everything down. It just does. It makes everything nice. Now, I can't even remember what I showed you, what she had to say. I think I did. Yeah, so she's saying that it's just, they can't account for it.
There's absolutely no way that we can explain this observation with our current understanding. In fact, the only way we think we can explain what's going on is if there are new particles in the universe associated with new physics processes beyond those that we understand.
It's electron flood theory. I understand it. Give me a call, I'll tell you. I'm serious. I've been trying to get a hold of people, and you know, you show them all of the stuff, and you know, there's not much they can say other than to just go away, and that's what happens. So sooner or later it's going to have to be addressed because it's the only thing that really does work. And I mean, I can explain everything. I can explain the Schumann resonance frequencies, which are extremely, I don't think anybody else can explain them. They say, oh, it happens because of lightning accumulating in the atmosphere. Well, how does that happen? Why does the lightning accumulate in the atmosphere and then discharge at certain rates to give us a frequency? And why is there several frequencies? Like there's, I forget the numbers, but they jump, you know, say 7 and then 14 and then 30 and then they go, I mean 21, I think it goes 7, 14, 21, I forget right now. But it's not an equal number. And I understand why we're getting them. And I understand why the electricity is being generated in the atmosphere. And I'm going to tell you right now, we are in for a hell of a lot of electricity. We are overcharged, and there is literally nothing can be done about it that I can think of. I'm sorry, that's the bad news, but it's bad news, and there's nothing I can do about that. All right, so we're scrubbing through space, which has particles in it, which push back against us, which heat our atmosphere in our ionosphere thousands of degrees, and create our magnetic field, because it's a magnetic push against our magnetic particles that are in our atmosphere. It has now, however, pushed so many electrons into our earth and our waters and our buildings and our cars and our waters and our soils that it can't take it anymore. We're at a capacity. There's certain things they call capacitors. They will absorb a certain amount of charge, and then at that point, you keep going and you explode. Just pop like a cork. Now, what's going to happen to the earth? I have no idea. But I can tell you what, every time we burn, you know, they talk about CO2, you know, greenhouse gases. It's not the gas. It's the expansion of the particles. If you took this, if you took that rock, and you burned this so hot that all of the particles had turned into dust, all of those particles would turn into huge balls, each one of them, creating a region in space that it owns now because it's been liberated from its base. And that happens when you take coal. You take a chunk of coal, you put it in there, you burn it up, it burns by itself. And by grabbing oxygen and you know, everything goes together and you get carbon dioxide. Well, yes, absolutely. However, what you're getting out is a ball of this and a ball of that and a ball of this, where before you had a chunk like this. And after you burn that up, this weighs almost nothing, but in your air you heated your whole house. Think of how much more region in space this becomes occupying when it burns versus when it's all attached to each other. It's a absolutely unbelievable number of difference. It's not that carbon dioxide traps the gas, I mean, the heat down, and it might do a little bit of that. I can't say it doesn't, but I can tell you one thing: it's the emission of electrons, which every electron is this big. Is this big? Well, I'm not saying exactly. It's 21 centimeters. No, it's not even 21 centimeters. Let's say it's that big around. But I'm telling you, they own a region absolutely enormous. And you push those electrons into something, that's what makes water bubble, that's what makes heat. That's what it is. So we got to start looking at this. There's no way they can account for what they're seeing now. And there's other articles that say exactly the same thing. The new bosons have been seen. It's the boson that we are showing, and that closes the case on it. And as far as I'm concerned, that puts us into an electron flooded universe. And Mudfossils is just a whole nother issue. All right, this is Nova on public broadcasting. And this is how you can actually see subatomic particles at your house.
Condense into a cloud of...
All you're doing is taking alcohol in dry ice, and it makes a very condensed liquid, and then the particles of light shooting through there, subatomic particles. They think they're cosmic rays and so forth, but you could do it with any really energetic particle. You're going to get this. When we shoot it through the Venturi, that becomes as energetic as it gets.
Of liquid droplets. So if a muon or electron from a cosmic shower shoots through the vapor, a cloud of droplets forms along its path.
Now, why does a cloud of droplets form? It's bashing into other electrons, and they literally disassociate them, and then they blow up to their balloon state. That's what's actually happening.
As amazing as it may seem, every line that you see in your jar comes from a subatomic particle. You've revealed...
All right, so there's just zillions of them everywhere.